Hello, SHAZIZZ here. What we have here is duct tape and baling wire. That loud obnoxious sound back there, that clack and clack. Yeah, let me slow it down. And on live. That's a lot of racket, man. Alright, well, give me a second here. There, gotta charge my battery back up. While we're jaw jacking, I need that on there. And I'll need that on there. Really? Gonna give me a rash? Alright. To 12.5 now. Alrighty. Duct tape and baling wire. It's everything I got around here is duct tape and baling wire. That right there, in case you missed it, is a neodymium magnet accelerator made by yours truly, old SHAZIZZ, back in 2019. There's only 2 of those prototypes in existence. One I gave to my buddy Rich, and the other one is right here. Anyway, this thing has got a few capabilities that if I can ever get all this thing sorted out, I think you'll be satisfied with it when it's all said and done. And it'll be a nifty little teaching tool for teaching you about how this electricity actually works in magnetic fields and such. You know, I'm not going to get into a whole bunch of high-tech terminology and all that kind of stuff. But these little motor controllers right here, this is a little 30 amp motor controller for an RC car. I can run those huge, I'll just spin you around here. I can run those motors off of these same little 30 amp motor controllers. And they don't have to run at super top speed or anything, because that's not what I'm going for. It's efficiency that I'm going for. The opposite side has an identical system on there. I get that receipt out the way. And they got little motor controllers, with those circuit boards that basically run that setup right there. And I can speed it up, slow it down to whatever I want for whatever hertz range I want because of the way that I've designed this flywheel right here. So when it's all said and done, this gizmo over here that you just saw doing all the clacking in for about 10 minutes prior to the deal. I know it's obnoxious and, you know, noisy as all get out, but when you see what, hold on, I got to get back over here again. When you see what that back there and this right here, that right there, and that right back there are capable of, when they're all together with a nifty little gizmo that's right up here at the top that's been in some of my prior videos. I think you might like it. But in the meantime, Got my mad science hair going, and I'm working on a few things so that I can start getting this doggone channel doing something. So I'm getting old and I ain't got time to be jacking around with monkey business or arguing with some little young man over the laws of physics and listening to him misquote the conservation of energy and thermodynamics and all that. I ain't got time to be playing around with all these different folks telling me, well, you should be researching this and you should be researching that, and have you looked at this one over here and this one over there? And I'm trying to tell these jive turkeys, but they're not hearing it, that I don't need to look at this over here. I don't need to look at that over there. I don't need to research this in here. I already got this situation under control. Now, they said they wanted clean, renewable, alternative energy and a way to store it. That's what I got. Now, why it takes me so doggone long to get anything done is driving me freaking bonkers. I got a couple more things to do to that one right there. I got to reload this track over here. I got to build a better track, because if you know that clacking going around there, that's because that magnet's slapping on a little lip every time it gets to this side and this side, because I had to split them and put them in two. I need a smooth track around that. And then when you see what I'm going to actually do with this right here, I think you're going to be happy about it. Now, at some point, I might actually try to look for some investors that want to build a kit for them that you could put these things together and you can send them off to schools, and you can, you know, it's almost like a magnet accelerator, the Hadron Collider. You know, they got that magnetic field and they spin a particle this way and they spin a particle that way and they get them going around real fast and slam them in the air. But we're not going to slam nothing into nothing. I just want to show you something cool about the magnetic field that I'm pretty sure that the folks that built hard drives and a lot of the cool gizmos you got now already have knowledge about what I'm trying to show you with that particular gizmo right there. For whatever reason, they don't teach it in school, which they probably should, but they don't. And since they don't, it makes a pain in the neck for people like myself who's trying to tell everybody, hey, you already got the solution. What's the problem? You know, what's taking so long? Well, in my particular incident, what's taking so long is obviously, you see, there's like a crowd of junk all up in this doggone place, because if you go back and look at my video called Forces of Darkness, you can see the damage in my old lab from the flood. And if you go look at my video, I don't know which one it was called. It was one or two back where I talked about the electron and asking you if you want me to revive it so you can see that thing work again. You know, but the deal is, I got this much space and I got a lot of stuff, and I need to get it all in order so that whenever you're looking at it, you can see exactly what I'm talking about, and everything's lined out so there's not a big old cluster of wires. You know, try to explain a schematic on that big old jumbled mess. I need some room where when I lay these things down, there's a guy, Daft Man, he puts these things, these pictures together for schematics, and you could just lay your wires right on the top of it and follow the schematic and solder them in, just like, all you have to have is a picture of the dang thing. I actually got a couple of his pictures that I printed out, but you could just follow it and you can connect all the wires exactly the way and the circuit works, and then you solder them up and it's done. So what I want is enough room for, you know, all these projects to go in their proper order. And I want to tape down with all the right color, you know, red for the red wire and black for the black wire. I want to tape them down so that whenever you see it on the table, you already have the schematic. it's already ready to go. I don't have to sit down and explain to you, you know, what a resistor or transistor or MOSFET or anything like that. You've already got it. And you got the numbers and the place where I order every single part of what I'm doing, so that when this thing's all said and done, then I put it together and I show you the capabilities of what I'm talking about. Then at that point you're interested in doing that, well, then, hey, you'll benefit, you know, greatly on the deal. As far as making maybe some 3D printed kind of base for these things right here, and maybe vacuum forming, if I can find somebody who does vacuum forming fairly reasonable and can replicate this size in, you know, like some acrylic, so that you can still see in. I want you to be able to see in it. There's a purpose. I keep saying the reason why I want you to be able to see in everything, because I want you to not only know that it works, I want you to be able to physically see the mechanics in motion, so that you can get it in your mind exactly how you'll know how it works. You'll know how to replicate it. There ain't gonna be no ifs, ands, or buts about it. And all the parts are parts that you can get right off the store shelf. And so if you start off, when I start doing the first series of Here It Is, then there you go. You'll follow along with me, and put it together exactly like I put it together and show you. I'll explain to you all the way through the entire deal, exactly how I'm doing it, why I'm doing it, what its ultimate goal is going to be for each and every one of these devices, plus the one up there. And it'll be a pretty cool thing for you when you see how it goes. And at any stage you stop out, hey, you got a neodymium magnet accelerator. But if I can get some folks to help me put together some kits, I can ship these kits out to you so that you can work with it and test it out for different things while we're working these projects together. And so when you got your neodymium magnet accelerator in there, by that time I'll probably be a couple videos down the line, but you can go back and watch that video and set it up step by step, just like I showed in the video. And so you already got that stage done. And if after that time you're not satisfied with that deal, hey, you know, at least you got a nifty toy to look at. It's a lot more than a toy, but you know, as long as you just like to sit around and watch things spin really, really fast, then it's a pretty neat deal. But it's got more capabilities than that. And when you see what I'm talking about, it's going to make perfect sense to you. It'll blow your doors off, and you'll think, wait, why ain't somebody already done this kind of stuff? Well, I'd ask that same doggone question, but most folks, it is what it is, you know. I ain't saying that people are dummies or anything like that. I'm not trying to be rude to nobody. It's just that the way that they teach people in school these days, they don't give you that thinking outside the box thing, you know, that where you're literally thinking outside. For when they show you something, they say this is the known laws of physics, this is you know, conservation of energy, all this kind of stuff, and this is why we say this. This is because we can't overcome this particular hurdle. And then you think to yourself, well, hold on a second. Why does that got to be a hurdle? If we know that something like the lens effect will actually cause, you know, eddy currents or whatever, you know, cause heat in this thing, now we know how we can actually intentionally put heat somewhere. Or resistance causing heat or whatever. Current flow through a piece of wire like nichrome or tungsten. Yeah, about to drop that doggone thing. That's what I'm talking about. Everything's in the doggone wrong dang direction. It's all cluttered up and it's hard to work, so that slows me down. I need my lab finished. But this is nickel chromium wire here, and it's set up so that when you put when you put a lot of current through there, it'll get hot. It's just like the little heating elements in your deal. Well, what if I told you you could also heat that thing up with high voltage, high frequency as well, without all the current? You'd call me a nutcase. But if you go back and look at my doggone video, vacuum spark gap, I think that one was called, I took an old burnout headlamp, the element burnout in there, and I shot 20,000 volts across that thing, with a Beckett oil burner igniter, and it's only in the milliamp range. That oil burner igniter's up there. You've seen it in some of the videos. So it literally, high voltage, high frequency, literally leaped across that gap, heated that doggone tungsten up, and lit that light bulb up. So I had 2 for 1. I got some light out of the deal, plus I could use it for a smooth vacuum spark gap, so that I'm not being interfered with any atmosphere around, dirt particles or wind. Nothing interferes with it. Give good smooth signal. Anyway, if you go back and look at all my videos, you're going to notice one thing. My lab was a junk pile. My new lab ain't going to be a junk pile, because I already got figured out what I want to put in there that is show you the final product of what I've been talking about the whole doggone time. The things that you can do with plasma, the things that you can do differently as far as the way you use electricity. You'll still have a use for AC current. You'll still have a use for DC current. It's not going to change. We're not reinventing the wheel. What we're doing is going for an extreme efficiency that could borderline, who knows, maybe even exceed on what that taboo word is, free energy. And of course, that's a national security risk, because we're on the petrodollar. They got to make up their doggone mind, man, because they're saying that we got to go to electric cars, and they're going to try to ban your gasoline cars and all this craziness, And so they said they need a clean, renewable alternative energy. What they don't want is it to be free to you. They want you to be able to pay for it. As long as you're paying for it, then all's well. It ends well and such. But you know what? If I show you how to use this stuff properly, and your appliances last longer, and you got more power for less input, here we go. Oh, you never can get out more than you put in. Shut up and sit down. I ain't trying to get out more than I put in. I'm trying to use what I got efficiently so that I'm not wasting, because the majority of the energy that comes through that wall socket is wasted in heat. There's so much loss in the systems of the way that these things are engineered these days. I don't know if it's flat out intentional to charge you more electricity, or they just didn't take the time to try to figure out why it is that your windings in your electric motor were getting hot, and eventually it'd reach its thermal breakdown point, and the insulation would fail and the motor would burn up. I don't want my motors to burn up. I want them to last. If I buy a fan, I want it to last for a while. So put a little oil on the bearings, keep the temperature of the electric motor from exceeding its thermal breakdown on the insulation, and doggone it, that motor will last forever and a day. There's motors that have been built back in the 1800s, or probably even prior, I don't know, that still work to this very day. An old antique fan still working to this very day. Ain't that a surprise? I wonder why. Some of them old fans had little oilers on there. Every once in a while, you just drop a little bit of oil down there to oil the bearings, but that was it. You'd be surprised at what they had back then. So taking a little bit of what they knew back then, matching it up with a little bit of what we know right now, and some thinking outside the box, and not allowing somebody to tell you, that's against the laws of thermodynamics. That's against the laws of conservation of energy. Once again, shut up and sit down, young man. Just pay attention. You might learn something. Look, I ain't trying to be a jerk to nobody, but I'm getting tired. I'm getting old, and I want to get this stuff out to the world so that it's done, and we can just move on from there. I'll just retire and go fishing the rest of my life. And, hey, they said they had a problem. I stepped up to the plate. Took a lot of mocking and ridicule and cursing, and all craziness went on with all this dang stupid stuff out there that I can't talk about on here, because if I do, they'll whack the video or put some sort of disclaimer down there. And, Not to mention the jerks calling up there and telling me all they want to kill me and stuff. I don't bring it on. I may be old, but I'm a little scrappy, so we'll get to it if that's what you want to do. But let's prefer peace over you know, all that knuckleheadery or whatever you want to call it, BSery. Is that a word? It is now because old SHAZIZZ said it. So I coined the phrase if it ain't there yet, so got my stamp on it. Anyway, that's a neodymium magnet accelerator. It's not going to beat all heck. It's kind of like if you put an old bent camshaft in your car, you know. Clackety clack, clack, it ain't going to work right. Or if you don't adjust the tappets right or whatever, you know, the lifters. And this right here is a one out of... what in the heck was that doggone video there? Oh, teaching tool. Alright? There's a reason why I'm doing things the way I'm doing them. First off, I don't want to get shot. Your continuity of government, you know, national security risk, all that kind of stuff. You go try to see all these guys that tried to patent up some specially typed devices, you know, and they work too good. So I'll give you a piece of it at a time, show you what this can do. So once you got that, you know, wink, wink, nod, nod, that kind of thing. Hey, I already know how to make a neodymium magnet accelerator. That's a piece of cake. Well, that's a gear in the machine. The doggone right there, that circuit right there, there's some things that you can learn from that. My friend Chris Maresh, he actually built it, and he's pretty impressed with what he's been able to do with that thing. So it's replicatable. I already know that. And moving around on this side over here, you know, that customized generating system right there, you're going to like that because you can literally tune the frequency range to suit your needs, speed it up for higher voltage, lower current, or slow it down for higher current and lower voltage, that kind of thing. See, that's the whole thing, man. These folks don't think I know what the heck I'm talking about. Hey, dude can think this up in his head and go through all the trouble trying to explain to somebody what I need them to make, and now you got a neodymium magnet accelerator. Came from dude's head. Alright, you got this right down here, the teaching tool. Same thing, come from a dude's head. And I even show you how to get electricity off of one wire, that one light you were seeing down in there. One single wire is all it took, you know, running through a little coil, and that magnetic field, there's enough of that magnetic field to energize that. And, you know, those are little fluorescent, you know, like not fluorescent, neon bulbs. Go up and look how much voltage it takes to light up a neon bulb as bright as you saw over there. Anyway, it's neither here nor there. Working on getting my lab together, trying to get everything situated. Apologize for the lengthy section of the clackety clack clack, but you needed to see that running for that long for a reason. Most folks are probably not going to stick around as long as you did. The ones who skip ahead, hey, it's all right. You'll go back and watch it again one day. Mark my words. You'll go back and watch it again. You'll maybe turn the volume down a little bit and pay more closer attention. But it's all good. Anyway, folks, I'm going to shut this down because this is a long deal, and I don't know if I'm even going to be able to upload it, so I'll give it a shot. Anyway, peace and love, everybody. Take care. Stay tuned. Gotta find the button.